So rule number 3, if omega is greater than 0 and p equals 2 pi over omega, then the average of the product sine of omega x plus phi 1 cos omega x plus phi 2 for the interval 0, p or 0, np is equal to 1 over 2 sine of phi 1 minus phi of 2. So now we want to go through this second rule very quickly. So let's prove rule 3. So we start by writing that the integral of 0 to p of sine omega x plus phi 1 into cos omega x plus phi 2 dx. Let's say this is equal to I, for instance. So rule 3 says that if omega is greater than 0 and p is equal to 2 pi over omega, then the average of the product sine of omega x plus phi 1 cos omega x plus phi 2 for the interval 0, p or 0, np is equal to 1 over 2 sine of phi 1 minus phi 2. So let's prove this very quickly. So we start by writing the integral from 0 to p sine of omega x plus phi 1 cos omega x plus phi 2 equals to I. So this is equal to 1 over 2 integral from 0 to p of sine 2 omega x plus phi 1 plus phi 2 plus sine of omega phi 1 minus phi 2. So, and this is so because we know that sine 2 sine a cos b, for instance, 2 sine a cos b is equal to sine of a plus b plus sine of a minus b. So we should take note of that. So this implies that, so if 2 sine of a cos b equals sine into a plus b plus sine into a minus b. So we can also write the expression as equal to 1 over 2 integral from 0 to p of sine of 2 into 2 pi. We know that p equals 2 pi over omega. So omega will give us 2 pi over p, 2 pi over p, then x plus phi 1 plus phi 2 plus sine of phi 1 minus phi 2 dx. And this gives us 1 over 2 into minus p over 4 pi cos 4 pi x over p plus phi 1 plus phi 2 plus x sine phi 1 minus phi 2 and in the interval 0 to p. So if we substitute the value of 0 and p into this expression, so we see that this whole expression will vanish. This whole expression will vanish. This will go, if we substitute the value of 0 and p, so this whole expression will vanish. So we'll be left with 1 over 2, 1 over 2 into p sine of phi 1 1 minus phi 2. Of course, by the time we substitute 0 into this expression, so this also gives us 0. It gives us 0. So, and this we can write as equals to, this is equals to our high that we have initially. So, we can then write that thus 1 over p I is equal to 1 over p integral from 0 to p sine of omega x plus phi 1 cos omega x plus phi 2, and this is same as 1 over 2 sine of phi 1 minus phi 2. And this comes to the end of the third row, the proof of the third row. Now let's take a look at rule number 4. If omega is greater than 0 and p equals 2 pi over omega, then over the interval 0 comma p or 0 comma np, the average of the product of sine of omega x or sine or cosine written as sine of omega x plus phi 1 sine of omega x plus phi 2, or the cosine cos of omega x plus phi 1 cos of omega x plus phi 2 is 1 over 2 cos of phi 1 minus phi 2. So now let's go over the proof of the fourth row. So from root 3, if we replace phi 1 with phi phi 1 plus pi over 2 actually. So we need to replace phi with phi 1 plus pi over 2. Then we have that 1 over p, the integral from 0 to p, sine of omega x plus phi 1 plus pi over 2 cos omega x plus phi 2 dx is equal to 1 over p integral from 0 to p cos of omega x plus phi 1 cos of omega x plus phi 2 dx. So if we note that sine of a plus b is same as sine a cos b plus cos a sine b, and we take a as omega x plus phi 1 and b as pi over 2, then we can see that the sine of omega x plus phi 1 plus pi over 2 is same thing as sine of omega x plus phi 1 cos pi over 2 plus cos of omega x plus phi 1 sine of pi over 2. So this implies that the sine of omega x plus phi 1 plus pi over 2 is equal to sine of omega x plus phi 1 cos pi over 2 plus cos of omega x plus phi 1 sine of pi over 2. So we know that cos of pi over 2, that is cos 90, gives us 0. So the expression reduces to sine of omega x plus phi 1 plus pi over 2, which is equal to cos of omega x plus phi 1. And this is the expression we have over there circled in blue. So now from root 3, also we know that 1 over p, the integral of 0 to p sine of omega x plus phi 1 cos of omega x plus phi 2 is same as 1 over 2 sine phi 1 minus phi 2. So if we replace phi 1 with phi 1 plus pi over 2, then we have that 1 over p, the integral from 0 to p cos of omega x plus phi 1 cos of omega x plus phi 2 dx is same as 1 over 2 sine of pi over 2 plus phi 1 minus phi 2. And this gives us 1 over 2 sine of pi over 2 plus, now we take phi 1 minus phi 2 together. So, and this eventually gives us 1 over 2 sine pi over 2 cos phi 1 minus phi 2 plus 1 over 2 cos pi over 2 sine of phi 1 minus phi 2. And this is equal to 1 over 2 cos of phi 1 minus phi 2. So now to rule number 5. So if we take phi 1 equals phi 2 and equals phi in rule number 4, then we have that 1 over p, the integral of 0 to p sine squared of omega t plus phi is equal to 1 over p is integral from 0 to p cos squared of omega t plus phi, and this gives us 1 over 2, or it can be written as 1 over p integral from 0 to p sine squared beta, which is equal to 1 over p 0 to p cos squared beta, which is equal to 1 over 2 for omega t plus phi equals beta. So now let's take a look at some examples. So the first one is if I equals a1 cos omega t plus c1 sine omega t plus a3 cos 3 omega t plus c3 sine 3 omega t, and E is equal to b1 cos omega t plus d1 sine omega t plus b3 cos 3 omega t plus d3 sine 3 omega t. For a complete cycle, we have to find the RMS value of the current. That's the first question. So the second one says that if I equals I1 sine of omega t plus A1 plus I3 sine of 3 omega t plus A3, and E is equal to E1 sine of omega t plus B1 plus E3 sine of 3 omega t plus B3. For a complete cycle, we have to find the average value of the power and also show that E bar bar is equal to the square root of E1 squared plus E3 squared divided by 2. Solution. Let's go through this one after the other. So for the first one, so the two frequencies in current and omega, that is omega and 3 omega. So the possible periods are P1 equals 2 pi over omega and P2 is equal to 2 pi over 3 omega. So therefore the LCM or the integral multiple gives P equals P1, which is equal to 3P2, which is equal to 2 pi over 3. And we know that power is equal to EI. So the average power, therefore, is equal to 1 over P, the integral from 0 to P, EI dt. So if we put the value of EI into this expression, we have that 0 to 2 pi over omega, that is 0 to P, and P is 2 pi over omega, as you can see, into A1 cos alpha plus C1 sine alpha plus A3 cos beta plus C3 sine beta multiplying by B1, that is beta 1, okay, B1 cos alpha plus D1 sine alpha plus B3 cos beta plus D3 sine beta dt. We should note that alpha in this case is our omega t and beta is our 3 omega t. So from rule 2, we know that integral from 0 to P cos alpha sine beta dt is equal to 0 to P cos alpha cos beta dt, and this is also equal to 0 to P sine alpha cos beta dt, which is also equals to integral from 0 to P sine alpha cos beta dt, and these expressions are all equal to 0. And also from rule 5, we know that 1 over P integral from 0 to P cos square alpha dt is same as 1 over P integral from 0 to P sine square alpha dt, and which is equal to 1 over P integral from 0 to P cos square beta dt, which is equal to 1 over P integral from 0 to P sine square beta dt, which is equal to 1 over 2. So if we keep only the square terms for the product, we have as average power 1 over 2 into A1 B1 plus C1 D1 plus A3 B3 plus C3 D3. So for the root mean square of current, we know that our root mean square I bar square is given as 1 over p from integral from 0 to p I squared dt. So this is equal to 1 over p from 0 to p a1 cos alpha plus c1 sin alpha plus a3 cos beta plus c3 sin beta all squared dt. So if we multiply this expression, we expand the expression inside the square. So we have 1 over p integral from 0 to p a1 squared cos squared alpha plus c1 squared sin squared alpha plus a3 squared cos squared beta plus c3 squared sin squared beta plus and so on, then dt. So from here we have our expression as 1 over 2 a1 squared plus c1 squared plus a3 squared plus c3 squared plus 0, because all the remaining expressions after the square, give us 0. And we also know that the integral of a1 square cos squared alpha 1 over p a1 square cos squared alpha is equal to 1 over 2. So integral of 1 over p a1 square cos squared alpha will give us a1 squared over 2. Likewise, integral of 1 over p 0 to p c1 squared sin squared alpha will give us c1 squared over 2. Also, 1 over p integral from 0 to p a3 squared cos squared beta will give us a3 squared over 2 and so on. So eventually, if we take the square roots of both sides, we have that our root mean square, which is I bar is equal to 1 over the square root of 2 multiplied by the square root of a1 squared plus c1 squared plus a3 squared plus c3 squared. Now let's go through the second question. So the period is LCM of 2 pi over omega and 2 pi over 3 omega. So this implies that the period is equal to 2 pi over omega. So for the average power, this is equal to 1 over p, the integral from 0 to p, ei dt. And this is equal to 1 over p, integral from 0 to p, I1 sine omega t plus A1 plus I3 sine 3 omega t plus A3 multiplied by E1 sine omega t plus B1 plus E3 sine 3 omega t plus B3 dt. And this is equal to 1 over p integral from 0 to p I1 E1 sine omega t plus A1 sine omega t plus b1 dt plus 1 over p integral of 0 to p I1 E3 sine omega t plus A1 sine 3 omega t plus b3 dt plus 1 over p integral of 0 to p I3 E1 sine 3 omega t plus a3 sine omega t plus b1 dt plus 1 over p integral of 0 to p I3 E3 sine 3 omega t plus A3 sine 3 omega t plus B3 dt. So this is equal to I1 E1 cos A1 minus B1 over 2 plus 0 plus I3 E3 cos A3 minus B3 over 2. And this is equal to 1 over 2 into I1 E1 cos A1 minus B1 plus I3 E3 cos A3 minus B3. Now for the current, we know that the RMS is equal to E bar square, which is equal to 1 over P integral 0 to P E squared dt. So this is equal to 1 over P integral from 0 to P E1 sine omega t plus B1 plus E3 sine 3t 3 omega t plus B3 all squared t. So if we expand, we will have 1 over P integral from 0 to P E1 squared sine squared omega t plus B1 plus 2E1 E3 sine omega t plus B1 sine 3 omega t plus B3 plus E3 squared sine squared 3 omega t plus B3 dt. And this is equal to 1 over 2 E1 squared plus 0 plus 1 over 2 E3 squared. The required RMS, that is E bar is equal to E1 squared plus E3 squared, that is the square root of E1 squared plus E3 squared divided by 2. And this comes to the end of this question, solution to question number 2, and the end of this lecture. Thanks for watching.